Greetings, everybody. Are you ready for number 1 for our Module 2 Excel report? We are going to be talking about the half-lives of medication. We're going to start by looking at the half-life of ibuprofen. I'm going to walk you through that one, and then you're going to choose 3 other drugs that you might want to look at the half-life data for. We are going to follow a link to a Wikipedia page to get a chart that shows us how to deal with half-lives. We're going to create a chart in Excel that shows the number of half-lives that elapse, the fraction remaining, the percentage remaining. We're going to find the half-life regression, like I said, of ibuprofen, and then you're going to go on your own to find the half-life of 3 other drugs that either you're familiar with, you're curious about, or that you just randomly choose off the internet. You're going to create a scatter plot, and then we're also going to look in our scatter plot. We're going to look at each of the drugs' half-life with a exponential curve. We're going to put a trend line in that. We looked at a linear trend line back in Module 1. This time we're going to look at an exponential trend line. You'll see it's not hard once you know how to do it. We are then going to have a discussion about how many times you can divide a number in half, which goes along with half-lives, and that's pretty cool to see how many times you can actually divide something in half. We're going to look at an asymptote. Many folks have never heard that word. We're going to define the asymptote and look at the reason why it happens and relate it to the information for our scenario. We're going to look at the letter E in mathematics. We're going to learn that the letter E is just like the number pi. It's a transcendental constant that happens as a ratio when we divide things by each other. We'll look at that when we get to it. And then we're going to talk about how a trend line could be helpful, an equation of a trend line, and then also talk about why knowing how to calculate half-lives of medication might be beneficial to us. All right, let's go ahead and look at our Excel page here. You can see I've already started setting up my Excel page. I have down at the bottom, I have my sugar consumption, fat consumption, vitamin D, and now my half-lives of medication. And you guys can label your sheets how you want to. You might have more than 3 sheets. That's perfectly fine. You could have 6 sheets right now, or even 9. So you're ideally 3 sheets for that health statistic would have been good, but as many as you have is perfectly fine. So I went over to my document and I just copied and pasted half-life of medications, and that's what I'm labeling this page at the bottom here and up here at the top. So now I'm ready to start building on my Excel. To do that, the first thing I'm going to do is follow the Wikipedia link listed for number 1 there, and you guys can either click on it. Yours is in a PDF, so you should be able to click, or you can copy and paste, which is what I did. So once you copy and paste here, you get to your Wikipedia page. Yes, folks, it's true. Wikipedia can be changed by multiple people and may not always have the correct information. That is a true statement. This chart that we are going to collect right now from Wikipedia is a universal chart you can find anywhere. I chose the Wikipedia chart because it's big and easy to see. It was cleanly displayed. Just a quick little briefing about using Wikipedia for research. I do it all the time. You Google things, you find the best stuff on Wikipedia. So then you take your Wikipedia and you have all these little breadcrumbs that you guys can click on. And then at the bottom of your Wikipedia page is a reference page with external links. So you can follow all these breadcrumbs to find the data, legitimate peer-reviewed articles, if you need to go that far into your legitimacy, to find information that you need. Most instructors will not accept a Wikipedia reference, but you can follow the breadcrumbs on Wikipedia. That was just a little bit of free information outside of this math scenario. So now I have this chart I'm going to build. You guys can see that my number of half-lives elapsed, fraction remaining, and percentage remaining is going to take up more space than I have in a single Excel cell. So what I'm going to do is select 3 cells here. I am going to right-click, and you guys know how to do this. I'm just reminding you. Right-click, Format Cells, Alignment, and Wrap. and then okay. Now I'm going to type these in. I'm going to actually pause the video while I type these in. Okay, I typed them in, and then I pressed right here. I centered them both vertically and horizontally. That's what these little pieces do. And then I'm also going to make them bold, and what else? Color them. How about a nice peachy color there? And then I'm also going to fill them with borders. I'm going to go to my borders up here at the top. Recall, folks, that if your Excel is narrower than mine, then your borders will be here under font. So if your Excel is narrower than mine, you'll have to find some of your commands under these little drop-down menus. So don't get frustrated and think you don't have it. Some things you might not have if you have Excel from Windows 13. All right, so I'm going to click my borders. I'm going to go all the way down to line style, and I want my nice thick line. And this, you guys can also go back up here and change the colors too. Once I do that, I'm going to click my drop down again and click on all borders. And that'll give me some nice thick borders around everything, and that should become my default border now for the rest of this report, hopefully. So I have my chart over here. Folks, please use the pivots in Excel. Don't just type in all of these numbers. That's going to be really important now because I'm not going to type everything in for you on this Excel report. So please learn how to use these cool little features. I type in 0, and then in the next cell below, I type in a 1. And then I just simply click with my wide white cross cursor. I one-click, hold, drag, let go, move my cursor to the bottom right-hand corner until I get that thin black cursor, and I am going to click, left click, and drag it down. I'm going to go to 10. Now I want the fraction remaining. All right, well, let's look over here at our chart that says fraction remaining and percentage. Can you guys see that 1 divided by 1 is 1? That's 1 whole, which is 100%. Then it's half of 1, half, and then 50 is half of 100. And then I have a quarter. 25 is a quarter of 100. So every time I'm cutting these in half, that's a half-life. Very intuitive, right? So what that means is that here in my 2 columns for the fraction remaining and the percentage remaining, it's the same data. So I am going to type in a 1. And in the next column, what I'm going to do is hit equals. I'm going to grab the one before and divide it by 2. So now I have 1 divided by 2, which gives me 1/2. Now I want to apply this formula all the way down the line here. So I'm actually just clicking it with my wide white cross. A lot of people are confused because you can't do this when it's in cursor mode. You have to make sure that you just click in it with your white cross. And if you're in cursor mode, the best way out of that is to press enter. Because once you do math in Excel, if you click on another cell, sometimes it'll do weird stuff. All right, now one white click with the wide white cross cursor, and then take the little thin black cursor down to the bottom right-hand corner, double click, and now it brought it all the way down. I know it says fraction over there. These are not fractions. We're going to put it in fractions in just a minute. First, recognizing that the 2 columns are the same info, just represented in different ways, I'm going to go ahead and work smart, not hard. I'm going to copy this entire column, select it, Control Charlie, come over to the next column and Control Victor. You guys see these little green, Wiley calls those little green ants crawling around the side of that on my Charlie column there. I just press Escape and that goes away. All right, now what are we going to do next? This is where we get to do some fun stuff, use some fun features. I'm going to select this column of data. I'm going to go up here to number. I have, let me make this bigger. Where it says number up here, I have general. I'm going to right click or click the little drop down menu on the right and go to fraction. You see fraction down here? Do you see where it says a 1? You might not be able to see that, but once you click on fraction, you see it did a lovely job for my first 4 fractions, but then I have 0 for everything. And the reason for that is because if I round that fraction, it rounds it's closer to 0 than it is to 1. And my fraction tool, by default, will only allow 1 digit in the numerator and the denominator. So I have to do something. A couple different ways I can get to this screen. I'm going to show you guys how to do it using the drop-down menu, and then go all the way to the bottom where it says More Number Formats. Then you see on the left side it says fraction. It has a lot of other stuff too. So as we move along through using Excel, you guys can always look here for other options, how to change things when things get frustrating and your numbers won't do what you want them to. So now fractions, you can see I have an option for 1 digit, 2 digit, 3 digit. I'm going to check up to 3 digits. And we have other options, how we can have Excel round to some common fractions. All right, here we are, guys. Here are my fractions. This value is not given in a fraction, so I'm assuming that's why it wants to do that. This bottom one actually comes out with a number greater, with a denominator with 4 digits, so that one's not showing up. And that's fine, we're not going to be using it anyway. I am concerned about this one. I had not had this happen before, so I am going to just change that particular cell back to general and let it just be 1. Now on this side, we're looking for percentage. So I am simply going to select this, and at this point, because we're going to talk about this later on in this video, I want to point out that when I change a number to a percentage, the decimal moves 2 places to the right. So let's see what happens. The 1's going to turn to 100%, the 0.5 is going to turn to 50%, so my decimal moves 2 places to the right. I'm just going to go right up here to this percentage symbol and click that. Now again, you see my last digits are at 0, and that is because I'm not showing any decimal values. So right here to the right, you can see I can increase my number of decimal values or decrease. We're going to use both of these. Just the increase for scenario 1, we'll use the decrease later. So now I have increased the number of decimals, and I have a nice reading. I think the 10th place will do for our data. All right, guys, it's looking good. I'm going to go ahead and put my borders around my table, my whole entire table. I like how that looks. And I am going to go to my document and see what's next. We have found the number of half-lives elapsed, the fraction remaining, and the percentage remaining. Now we need to find the half-life regression for ibuprofen. So let's do that. I am going to go to my Google, and I'm going to ask Google, half-life of ibuprofen. All right, easy enough, huh? You guys like that? So I see that the half-life of ibuprofen is 1.8 to 2 hours. So I can choose my half-life. Do I want it to be 1.8? Do I want to be, say it's 2 hours? If I wanted to be better safe than sorry, I would choose, I guess I would choose the 2 hours, because then it would be lasting longer in me. But what I'm going to do to be more mathy is find the average of this amount of time. So we are going to go ahead and type in here the half-life of ibuprofen. All right, and look at that. Excel automatically colored it and made it bold for me. Cool. If yours doesn't do that, then you can just, right-click, align, wrap, do the whole thing again. And then for my ibuprofen here, I am going to, I have 1.8 to 2 hours. My half-life here is going to be, I'm going to put an equal sign to do math. I'm going to use my parentheses for my order of operation. So I have 1.8 plus 2. And then I am going to divide that by 2, because that's how we find an average. We add together the things we have and we divide by 2. And I know we probably knew that was going to be 1.9 in our head, but I want to show you guys how to do it, because the next medication you do might not be as simple. So now I know that my half-life happens every 1.9 hours. So every 1.9 hours, my ibuprofen loses half of its life. Now, I've started this chart here, and I just realized a second ago, that's why I might have seemed distracted, it came to me that I'm actually calculating my hours in this column. So I'm actually going to select this where it says ibuprofen. You see my wide white cross cursor. I am going to move that cursor to the edge till I get my weather vane cursor. Looks like a weather vane to me. And I'm just going to move that over. And then in this cell, I'm going to write hours. So now I've put 1.9 right here, but really this is my very first entry. So how many hours have gone by in my very first entry? Well, not 1.9. Move that one too, because my first hour is 0. Now, for my second hour, you have to be careful here. Sometimes people will double it. It would work for the first one. The first one is twice as many as the second one. But then after that, we just add 1.9 each time. So let's look. 1.9 hours goes by, and then we have 1.9 plus 1.9, plus the one above. So 1.9 plus the one above gives me 3.8. So by the time I lose 3/4, my half-life happens twice, 3.8 hours have gone by. So I'm just going to select this cell with the 3.8, come down to the bottom right-hand corner and double-click, and now I can see I go all the way to 19. It came out to be a nice round number there. Now, let's talk about the half-life of the ibuprofen. Well, at 0 hours, how much ibuprofen do we have? It depends. This data over here on the screen is giving us the ibuprofen starting at 800 milligrams, which is a prescription amount. Anybody who's ever been in the military knows about an 800 milligram ibuprofen prescription, because they do prescribe those, way over prescribe those in the military for our soldiers. So this is good because we're going to get to see how much of this stuff stays in your system for how long. A lot of times people might take an extra dose way too soon. So let's have a look. We're going to start off here with 800 milligrams. So we know at 0 hours we have 800 milligrams inside of us. And then for our half-life, well, half-life is very intuitive. It is simply half of the one above. Over here on these, whoops. I'll just show you guys. Over here, I used the one above divided by 2, right? Well, this is the same thing. I'm just going to do it different to show you. I'm going to do half of. So that's 0.5 of. Remember, when we say of in math, it means to multiply. So I have half of the one above. And then hit enter. And this is exactly the same thing as dividing by 2. Click this and double click. And now I see this data. So look, you guys, if say it's about 4 hours later and you still have a headache, your back still hurts, and you want to take another dose of ibuprofen, you can realize, wait, I still have 200 milligrams inside of me. So if my prescription's for 800 milligrams, then I would only need to take another 600 to get back up to that amount. Just remember, do some research and see what the ibuprofen does to your kidneys and liver before you decide to go about taking too much of it. All right, so this is looking really good. I'm going to go ahead and just select my whole chart, give it some more borders. Very nice. Now I'm ready to build my graph. You guys know how to do this, except you just might not know which variables to use. We are going to use hours and half-life. This is what our graph is going to consist of. So I'm just going to select those 2 columns. I am going to, well, let me make this bigger. Trying really hard to use your guys' feedback. You told me, Miss Binsey, please make your Excel's bigger in the video. So here we are, trying my best to do this. Select these 2 columns, insert a scatter plot with smooth lines. I think I put smooth lines in the instructions, but smooth lines with markers is even better. All right, here is my lovely chart. You guys, of course, are going to label your axes and your title is already up there, so that's cool. But on your axes, you're going to label your half-life, and then your axes down here, your axis for the x-axis is what? Well, it's hours. So let's go ahead and label that. And if you guys don't know, if you double-click a word, it will select the word. If you triple-click, it selects everything, usually. Not that time. Okay, oh, there, it worked. So this is hours. I'm going to go ahead and make that bold, make it big, bold, and how about blue? So make your graphs look nice, mess around with your axes labels and your titles. Now, I really wanted to make the hours stand out because we're going to talk about them. We, in our chart, we're counting by 1.9 hours. So counting by 5 hours on my x-axis doesn't give me the quick visual that I want when I look at a mathematical representation, a chart. So I am going to double click my x-axis, and then over here you see my bar charts. Some of you may have come up there, and then go to axis options. Now you guys can see your min, your max. If you look at this graph, you would be able to see that it starts at 0, it maxes out at 20, and my major is what I'm counting by, 0, 5, 10, 15, 20. I'm going to change this to 1.9. Yes, you can do that. Pretty cool, eh? Hopefully you could do that. 1.9. All right, I'm going to pause the video and figure out why I cannot do that. All right, that was quick. I figured it out. You see right here where it says automatic? I'm hoping, I haven't actually checked it yet. I'm just hoping that I can click this and then change it to 1.9. Yay. All right, so if it's clicked on automatic, you're going to have to change it to axis value, and then you will be able to change that number. So now my tick marks make sense. Now at a glance, I can look at this chart and I can see, is it going to let me, oh, a little bit of a delayed reaction. This is why we want to keep all of our mathematical models, our charts, and our graphs aesthetically pleasing, because when we look at it, we should not feel confused. At a glance, I should be able to see that after 1.9 hours, I have 400 milligrams of ibuprofen left inside of me. And at about 10 hours, I have almost 0 left. It's getting down there, isn't it? So our mathematical representations are meant to give us at-a-glance data. All right, let's go back to our sheet and see what we might be missing. I mean, I know what we're missing. I just want to show you how to look back at your sheet. And over here, I can see that I need to now, I created a scatter plot with smooth lines. Hold on. Okay, I just added in smooth lines and markers. We did that. Now we are going to, we labeled our axes and we gave it a title, and now we're going to insert an exponential trend line. So let's see what that looks like. Inserting an exponential trend line. Again, folks, if you have Windows 13 or earlier, some of these features will not be available, so the best thing for you to do is to use a computer at work, at school, a friend's computer. Try to find a computer with Windows 16 so that you can learn how to use updated technology. I am going to click the little green plus sign. Now, in the past, we have used a trend line that by default, Excel uses a linear trend line, but we do not have linear data here. We have, if you click the drop-down arrow to the right, you can experiment with some different trend lines. And when you go to exponential, you can barely see that sticking out at the top because the line fits so nicely over the top of my graph that I can hardly see the trend line. Now, we're not only interested in the trend line, so I do have to go down to more options here. We've already established that an exponential trend line is what we need. So, and you know, we have other trend lines. Our logarithmic trend line isn't going to work. Our polynomial trend line looks like it could be kind of close. That one would have worked well for Elon Musk's flame thrower. If we had the graph, but we had no equation to create that graph, we could have done it with this. You'll see here just a second. All right, so this is an exponential trend line. We are going to also go down here to the bottom, and we are going to display the equation on the chart. So click that, or click it twice if you have to. And now my equation is showing up over here. So this equation is real small, but it's a very important piece. So I'm going to move it up to the middle. Thank goodness for Control Zulu to undo crazy little things that happen. So I'm going to move that up there, triple click it, or just select it all. And then I am going to increase my font, make it bold, and just make it blue. Now I have this wonderful equation. Well, what does this equation do? This equation gives me an opportunity to be able to plug in any number of hours to see how much ibuprofen is left inside of me. So let's go ahead and label this as the trendline equation. And my trendline equation is equals 800 E. Here we go, folks. What is E? Well, let's ask Google. What does E mean in math? What is E mean? What does E mean? All right, so now I see that E in math is exactly
According to Math is Fun, the number E is a famous irrational number and is one of the most important numbers in mathematics. The first few digits are 2.71828184590452353602874713527. It is often called Euler's number after Leonhard Euler.
Okay, my computer reads me back what it's saying, and during that time, my video can't record. So here you see we have what's called Euler's number. It looks like Euler's number, but it's actually pronounced Euler's number. You can Google that too. This is a number just like pi. It's a transcendental constant. When you calculate pi, you measure the circumference of a circle and then divide that value by the diameter of the circle. And no matter what size your circle is, you always get pi back. So this is a similar ratio that comes up a lot in mathematics. So to shorten it, we just call it E. So coming back to our formula, since E is a mathematical representation of a number, Excel is going to know something about it, which is really cool about Excel. Before we type that in, I want to show you, anytime in math you have a variable, in this case it's not a variable, it's a representation of a constant, but no matter what, a letter next to a number means to multiply. So I have 800 times E, and I just type in the E there, and my E is this EXP at the bottom of the list, exponential. Now it gives me parentheses, so now I just put in the power that E is raised to. The power here is negative 0.365 times, again, you see the 365x, that means times x. So that's going to be times, and well, what is x? It's 0. X is my number of hours. So then I press enter. Excel wants to know if I meant to close the parentheses. Yes, I did. Fantastic. Now I'm just going to apply that formula all the way down. And look at that. Do you think it worked? Well, if I rounded this value, if I got rid of my decimals, if I decreased these decimals, it would round to the same values. So it's awful close, isn't it, you guys? In this case, my regression equation, my trendline equation worked. So I'm going to go ahead and get all this in a border. And here we have number one. Oh, I know the other thing that I wanted to talk about. Well, we have to look back at our page. So let's look back at our page. And here we see that we are going to discuss how many times you can divide a number in half. Let's go ahead and look at that. Okay, I'm going to make this smaller because this little experiment is going to require some extra space. You guys see where I took the number 800 for my half-life, and then remember we cut it in half? Every one of these formulas cut the one above it in half. So I'm just going to take this bottom piece, and what's going to happen? Can we divide that number in half? Well, I think so. And we're going to see how many times can we divide a number in half. I'm just going to scroll down. I'm going to go crazy here, scrolling down, maybe. Well, I wanted to scroll down more, but look what we ended up with just right here. I scrolled down 90-something spaces, and I get 1.03e to the negative 23. We remember what that means? That means I'm going to move that decimal to the left 23 spaces. So it's going to be 0.22 zeros and then a 1. That's a pretty small number. 0.22 zeros and then a 1. Well, can I make it smaller even still? Let's go. You guys remember a Planck length on the other end of the universe, how tiny a Planck length was? I want to say it was like e to the negative 64 maybe. I don't remember. Was it in the 30s? Look, now I've divided this number in half 218 times. And how small is my number? I'm going to move that decimal 61 places to the left. So that's 0.60 zeros and then a 1. So it looks like no matter how many times I divide a number in half, it's never going to hit 0. It's just going to keep getting 0.0000000. So how many times can you divide a number in half? An infinite number of times. I'm just going to press backspace and undo all of this stuff. One more time, hopefully. One more. All right, so now we see how many times a set of data can be divided in half, an infinite number of times. Well, what does that mean for our trend line, for our asymptote? We want to know what an asymptote is. An asymptote is a place on a graph where the data would be undefined. So in other words, this graph is never going to be able to touch 0. At 0, it would be undefined because we keep dividing it in half. So that line can keep getting closer and closer and closer to the x-axis, but it can never actually touch it. And if I took these values on my y-axis, and instead of counting by hundreds, I counted by 0.000001, 0.000002, in that case, I would actually be able to really see how the graph never comes down to cross the x-axis. Now this is called a horizontal asymptote. Sometimes we see vertical asymptotes, and in some sets of data we see multiple asymptotes. So in this case we have a horizontal asymptote on the x-axis, and it's not always on an axis. Sometimes it's stuck just somewhere, any place in a graph, depending on where that data is undefined. So here we have discussed an asymptote. We talked about how many times a number can be divided in half. We talked about what E is in a formula. And then we talked about a trend line equation could be helpful because we can plug a trend line into Excel or a calculator or even just Google and plug any value in for our number of hours and instantly see how much medication is left inside of us after that. And knowing how to calculate the half-life of medication is extremely beneficial because you should always know how much medication is inside of you, and especially if you're administering medication to children or the elderly, are especially sensitive to being over-medicated. So folks, remember now you are going to work smart, not hard. If I was you, I would literally just copy and paste this whole chart below, look up another medication, use Google, ask Google what is the next medication, what's the half-life, do the data, build the chart. All right, so you're going to do that 3 more times. That is the end of scenario number 1, and I will see you guys here coming up in scenario number 2. Until then, keep being amazing. You rock.